All right. Welcome, everyone. My name's Chris, and I'm from Golioth, and we're going to be doing this webinar here, just a little bit about what the webinar is. We're actually in a new area, new thing. We're using StreamYard here for the first time. If you have any feedback about that, we'd love to hear about it either in the chat, afterwards, before, whenever you think about it. You can always send us an email as well, devrel@golioth.io. We'd love to hear specifically about the webinar experience here, because we hope to do more of these in the future. Let's kick things off with a quick round of introductions from the speakers, myself included. Mike, why don't you go first here? If I can figure out how to. Oh, that ain't it. There we go. Mike, why don't you go first? Mike, you're muted there.
Good. Unmute. All right. My name is Mike Stish. I'm a developer relations engineer at Golioth. Since we're talking about where we're from, I live up in Wisconsin, where it's actually not that cold today. Kind of a nice place to live. I've been doing firmware for a long, long time and have fallen in love with microcontrollers in the early 2000s and have gotten really comfortable with Zephyr over a little bit more than the last year as I started work with Golioth.
Awesome. My name is Chris Gamble. I'm the developer relations lead at Golioth. You know, developer relations is a term that a lot of hardware folks that I expect to kind of be in the chat, hardware, firmware. Developer relations is kind of the equivalent of, is what the cloud world calls applications engineering. And so that's what Mike and I do. We do a lot of designs and we do hardware, firmware, software, all of the stuff there to showcase what Golioth does, but also, you know, what you could do in IoT. And it's been a lot of fun building that sort of stuff. My background is in hardware, so I've been learning a lot, not just from my coworker, Mike, but also from our esteemed guest, Jared Wolff. So Jared, why don't you take it away about what your background?
Hey, everybody. I see some familiar faces in the comments, or familiar names, I guess, not so much faces, but I'm glad to see you all here. Thank you so much for the opportunity to join the live stream with you guys. We haven't done one in a while, so it's exciting to do, to get together to talk about Zephyr, because it's a lot of fun.
Yeah.
For those who don't know me, I run the Zephyr 101 live stream typically weekly, depending on what's happening in the world. But I noticed you guys had written how much years of experience you had on the slide. So with everybody combined, we're more than 50 years of like hardware and firmware hacking, which is kind of cool. But more recently working on Zephyr pretty much daily, developing and also developing hardware. So the NRF 9160 Feather was kind of like my first jumping off point with Zephyr. So I learned a lot in these past 2+ years, and I'm really excited to share with all of you. So
great. Mike, why don't you talk about some of the things we're going to try and talk about here today?
Yeah, so I think everyone that's working with a cellular device or working in IoT hits up at a battery constraint at some point. And those radios, they suck up a lot of power. So we're going to talk today about different approaches, whether it be approaches with your hardware designs, with your firmware designs, and then also with your software designs, how your device is communicating with the cloud. What can you do? What can you plan for? What do you need to know before you start in order to get the best low power mode and the best battery life out of your devices?
Jared, what's the longest battery life you've seen for like a cellular device?
So not so much particularly my hardware, because I think right now with the older versions, I think you can get to between 4 or 5 months of, if you're very conservative. With the new version, you're probably going to multiply that by 4. Things that I've seen already out in the world that are really optimized are the things that I think of, like power meters, which run on these like optimized lithium batteries, which last 4 or 5 years. So those are, I know some of those are cellular, some of those are kind of like LoRaWAN type thing, but those are pretty impressive because they spend a lot of time beforehand to optimize their devices to make sure they're low power and things like that. But Zephyr helps you get there a lot faster, and you don't have to spend years doing that or hire a huge workforce to do that either. So
Right. Yeah, I think that's one kind of trend or one theme that we're going to see throughout the stuff we talk about today is just that trade-off. Because no matter how much you want your battery to last 10 years, if you're sending something every 10 times a second, it's just not going to happen, right? There is not, you can't overcome physics at a certain point. So it really is going to be, a lot of what we're talking about today is measuring and understanding what your device is doing. It's optimizing, like Jared was talking about, and making those trade-offs and understanding where it is. And then, some of it is also utilizing the newest technology, maybe a new node in silicon, a new capability that might be available to you from the cellular towers. We'll talk about some of that stuff, and then finally, like a lot of the tools and the ability to implement that optimization by using things like Zephyr. So we're going to talk about all those things today. So really, we're going to get down to hardware, firmware, and then software. So let's first kick it off with the hardware side of things, because I think that's really where a lot of the best bang for your buck comes from. And obviously, we're talking to Jared here, who creates hardware based on the NRF 9160. So Jared, could you tell us a little bit about maybe the 9160 kind of at a high level, and then we can dive down into how you utilize it on your hardware?
Yeah, so this is it was an interesting piece of hardware that I've been paying attention to long before it was like so I was using their NR5251 platform actually even before that, and I think the 8001, so their Bluetooth chips. And when I first saw this, I was like, oh, this is interesting. Like, this is cool. And then it just kind of like in the background, and they're working on it in secretive, and it's in these these Pelican cases, and like very secretive, but now it's here and it's great. So it's a dual core processor. One is reserved for kind of the LTE side of things, and then you have another processor dedicated to your application. And they've spent a lot of time making sure that in the hardware it's optimized for low power operation, whereas you can maintain an active LTE connection or an NB-IoT connection and use very little power. I think just standalone, just by itself, I think it's 2 microamps or 1 microamp in total. That's what I've measured in the past, without any other circuitry on the outside connected to it. So when you start adding some other stuff onto your board, you need to be very cognizant of how you're handling power for those things. But it's been impressive to work with. I think every time I've talked to people, they're very excited about the prospect of having something that's cellular connected and it's drawing a couple microamps. So very, very cool piece of technology for sure.
Yeah, that's great. And I think it is starting at a really good place here. Mike and I use it for a lot of our reference designs. That's what we mentioned that we're doing as kind of our application style role that we're doing. And we've gotten very, very comfortable with it. Again, thanks to your resources, the Nordic resources, and other stuff we've been doing on our own side of things. Mike, what has been your take on the hardware with the NRF 9160?
Yeah, so I like it because it handles the connection really easily for me. I don't really need to worry about that in Zephyr. But although if you do, as Chris is going to show off later in the webinar, if you do want to drill down and see what's going on with the network, you have the availability to do that. So kind of easy to get in as a starter, but there's plenty of room to grow with it. And then it's got plenty of I/O. Like, we've never had a problem with the I/O. Nice and fast. I mean, it's a good part to work with, and I've got maybe 3 of those boards within arm's reach at any time when I'm sitting at this desk.
Yeah. And I think one thing I think about with, specifically this piece of hardware is that the microcontroller is built in. If people, one of my friends I worked on a project with is also in the chat here, and we've used like external cellular modems. A lot of the times it's coming from like an AT command set. So that is a little different as well, having the integrated microcontroller. This is a trend that we're seeing more stuff coming into the embedded space, having onboard processing, that sort of thing. I think that actually does, and that tight coupling of, you're not working necessarily through an AT command set, you might be working through an API, right? And a lot of that's built into the firmware, like we'll talk about here in a little bit. Kind of generally thinking about it, like when we think about connectivity, IoT at a broad level, having all of the different things that are out there, they come in different flavors and different amounts of RF energy that you need to do these sort of things. None of them are particularly, I think Bluetooth is the one that a lot of people go to for super, super low power. This is definitely a high. These are not in order, of course, either. But so each of these things are going to have different power constraints in them, and then you also have the embedded side, the embedded processing as well. So like sleep modes and things like that. So let's talk a little bit about the actual hardware itself here, the board that we're talking about. This is the Jared's board here. So Jared, you want to walk people through what's actually on the hardware that you have designed here?
Sure. It's a so thanks to Adafruit, who developed the Feather platform. I used their Feather footprint, so it's everything that you would expect from a Feather. You have your USB port, USB-C, and it does have the CC resistors on there now for those who are interested. The previous version that didn't, so you couldn't get as much current out of it, and it wouldn't negotiate power distribution. So, but it's got the lithium charger on there, so you can hook up a lithium battery and some onboard NOR flash. So if you like to, I use this all the time for saving data on using little FS and Zephyr to put bits of data in there and use it to regurgitate when it's ready to publish to the cloud. Obviously, the NRF9160 is there. We got some external antenna connectors. So one's for the LTE antenna and one is for an active GPS antenna. So it does handle GPS. So that's one other thing that's really cool about it. It's just feature packed. It's got a lot going on. The only thing you don't see on the back end is on the back side is you got a SIM holder, so you can pop in any provider that you want as long as it works with Cat M1 and NB IoT and an accelerometer. So got a lot of stuff going on there. It also has a USB to serial adapter, so when you plug it in, you can talk to it. You can load new images to it directly over serial to USB. So that's the basics of the NRF9160 Feather.
Great. And so there's been, it says V5 here, right? It's been kind of changing over time. What are some of the recent changes that you've been pushing down in order to improve the power savings? Because it feels like a lot of that stuff is also going to make its way into people's, if they use this as a reference board for building their own hardware, they might also want to pull some of those changes forward to be more efficient.
Oh yeah, 100%. So some of it was actually just supply chain problems, just chips not being available at the time, just having no insight into when they were going to come back. Some of it was actually there were some hardware bugs, like the original version. It was not switching between PFM and PWM at first. And if anybody knows anything about a buck converter, it's always going to use a lot less energy in PFM mode. And that's generally what's used for kind of low current standby states. Still uses a ton of current, but better than nothing. Well, the cool thing is the new version actually has a chip from TI that is sub microamp current when it's quiescent current, no matter the mode. And that's been pretty impressive. When I discovered that, I'm like, I'm going to use that because that's amazing. Because that's just one less thing that's going to draw a bunch of phantom current when your device is not doing anything. Besides that, it's just been taking the input from customers. Some people have originally there were two Schottky diodes in there, one preventing backflow, but in this case, I removed one, so that allows anybody to provide 5 volts to the 5-volt pin to power the board itself. So just small tweaks here and there to improve quiescent current performance and also just usability. Also, like the new version has you can activate the bootloader with a command line code, so you don't have to use the buttons anymore. So that's been a kind of quality of life improvement for people developing on the platform. I use it every day, so it's nice.
Yeah, that's great. What about other like kind of hardware based things? So like one thing I always think about is like pull up resistors and things that are just kind of leaking current. Have you had to make other adjustments in order to optimize for that sort of stuff?
What is going on? I got like music playing in the background. So that's definitely a consideration for sure when you're developing any type of hardware. Is you're gonna try to be very cognizant of those things that are very static. Sometimes I actually will utilize the built-in pull-ups and pull-downs in the chip itself, depending on how strong I want it to be. So I can always turn it off when I'm not using it. A great example of a pull-up or something that's caused issues in the past is the accelerometer has a built-in pull-up. When it's reset, it just turns it on automatically. You actually have to issue a command to the accelerometer to turn it off because otherwise it draws like 200 microamps, which is not not good.
Right. Yeah. It doesn't sound like a lot at the outset, but then when you start thinking about all the other things that stack up here, yeah, that's, it's like basically like almost like instead of bug hunting, it's like current hunting, right? You're kind of like just working your way down and trying to eliminate the next and the next thing. What are some other things that you've had to eliminate in order to get it to lower and lower currents at a board level as well, right? Because like you said, the chipset itself has been pretty good.
So some things that, so I spent some time in this current version to eliminate just some parts and extra circuitry that it was useful, but it's just for simplicity's sake, just to kind of consolidate everything. So there was some power down circuitry that uses the RTC. There's actually an external RTC on the board as well, so you can kind of use it to keep time, even if the NRF9160 resets. But it's just a process to make sure that, especially one thing that comes to mind is the USB to serial part is making sure that that plays nicely with the NRF9160, especially when it's unpowered. So it takes some time to kind of to make sure when you power down everything, when it's in that low power state, that it's not back powering anything. That's the biggest thing that I've found in all the hardware work that I've done, and probably yourself too, Chris. Is just that's your worst enemy right there. Something unintentionally back powering another part of the circuitry, which then drives you crazy, because then you have to go and find it and then change the hardware.
Right. If anyone's ever seen like that dull LED turn on, like that's always whenever I see that, I'm like, oh, something I did something wrong here. So
not right.
Yeah, that's a really good point. Okay. And then, it's one thing that's as well, like it is built into the NRF9160 as well. Like it is made to basically be, I've seen a lot of the drawings saying like, oh, this is supposed to be battery connected to the module, the SIP, connected to an antenna. That's like the marketing thing they like to show. But then I think when you have the reality of building out a board, you're going to have other stuff around it. You might want to have power modes around it, right? Having lithium chargers, that sort of thing. So, you have to kind of just balance what the built-in capabilities are versus what you might want to do externally there. Okay, great. Should we move on to firmware? Mike, any other questions about hardware?
No, I'm ready for firmware. Let's do it.
Mike is our firmware guru. So, all right, let's switch over to firmware then. I guess we should start at the top and just talk about Zephyr itself, right? So Nordic adopted Zephyr and then kind of made it its own flavor. Nordic NRF Connect Studio NCS. You'll often see it annotated. And so, like Jared said, he used a lot of Zephyr. We use a lot of Zephyr at Golioth. We have other SDKs as well, but Mike and I are using Zephyr most days. And then I think some of it is kind of what is baked into the capabilities of Zephyr and NCS as well, right? That's kind of where we're getting here. And so there's two big things that I would think that we have available to us. And probably the top line should have been the PM library here. So this is actually a link that we can look at a little bit here. But I guess first we should maybe watch. Jared has a little clip here of the about the PM library, right? So we'll check that out.
All right, let's do this. Quick Zephyr 101 tidbit for you all. We're talking about PM device API and controlling your devices in runtime using the power management API. Maybe you have situations where you need to control the power subsystems or control a peripheral in runtime versus just kind of letting the system do it on its own. So we'll be doing a quick example here, and hopefully this will help you manage your power on your device dynamically. Let's jump in. So it will give you, so if you just enable the plain old config PM, the power management API, it'll give you some sane defaults, and that should, as long as your device manufacturer, as long as they have the good support and their drivers for this, should kind of do it on its own. But in some cases, you need to make some changes dynamically, maybe at runtime. Maybe you want to use your interface for a certain amount of time during runtime, shut it off when you're not using it. So the standard API, the standard kind of power savings setup is not there. So we have to enable the configuration, so the config PM device, and that will enable your power management device API to be called, and you can change things on the fly. So we're using it in this case, the UART console. There's some interesting things happening here. Let me zoom out. During a boot up process on, say, the NRF9160 Feather, there's actually 2 images that get called before you actually get to your code, to your application code. You have the bootloader, and then you also have the SPM, the Secure Partition Manager, or in newer versions of NCS is actually slightly different. But the main thing is here that there's actually several images that get loaded before you actually get to your application. What happens here is sometimes there's different drivers or something gets changed or GPIOs get set depending on the configuration of those sub images. So you could imagine things get turned on, they don't necessarily get turned off. So this is what we're talking about here. I'm going to jump over back to the slides. So we're turning off the UART because it actually gets turned on in the bootloader stage, and we'll disable it to reduce the power usage. And in only a few lines of code, as we'll see, you can get there where you can reduce your power usage by a factor of 4. Here's the configuration. As you can see, you have the power management device API and also just turning on power management in general. One thing we're going to be doing in the code first is just getting that device. So we're using UART0 in this example. We're just getting it through the device DT get macro. Pretty standard stuff. Now we've created this static function. It is called during the initialization of this application. It's called setup UART. Just making sure that the device is ready, it's initialized, there's nothing wrong there. You're typically never going to get this error, but you never know. So it's always good to check. And then you have, what we're doing here is, okay, we're assuming that the UART module has been turned on. So first thing we want to do is make sure that the receiver is turned off. The receiver on the UART peripherals, at least on the Nordic chips, are very expensive. If they're running, they can be up to 1 milliamp of current draw, so you need to be careful about that. And then we give the UART peripheral about 100 milliseconds just to kind of settle. The last thing we want to do is actually call that PM API. So what we just enabled is this PM_device_action run, and we're going to be running the PM device action suspend. So there's a list of actions that you can do. You can restore a device from suspension, and you can also suspend it, i.e. turn it off. And this is the most important part right here. This is the API call we're talking about that will make the difference in your application. And here's some quick measurements. You can see without calling this UART function that we just created, we're drawing about, on average, 20 microamps of current. Now, this is surprising. I am using a newer version of NCS, and I was expecting about 1 milliamp, so somehow it's only 20 microamps. Not sure what happened here. Maybe the receiver was already switched off. That's the biggest thing that will cause it, but in this case, we do actually have some savings, some power savings. So if we jump to the next slide, so keep this in mind, 20 microamps. If we jump to the next slide, you can obviously see at the same time frame, you can see the same on the Joule scope capture here. There's a lot less activity. There's a lot less stuff going on. So on average, we're drawing about 5.4 microamps, which is almost a factor of 4, which is great. And as you can imagine, if there was other things turned on, you turn them off, you could save a bunch of power. So in this case, this is the NRF9160 Feather in an active sleep. So it's sleeping, it's on, but this is kind of like the lowest amount of current that you'd be drawing when it's on and active, and you have the buck converter still running. So using the device API for runtime changes, it's great for dynamic. So if you're changing things on the fly, if you want to turn on console for a little bit for configuration, and then you want to turn it off later, this is a great option. Otherwise, enabling the standard power management APIs that do the automatic stuff should work in most cases, and it'll help you get most of the way. But if you have some kind of special dynamic things going on in your application, you definitely want to check out the power management device API. That's it for this tidbit. Thanks for watching, and see you on the next one.
All right. It's weird seeing Jared and then back to Jared. So yeah, we're back to Jared.
Back to Jared.
Yeah, so that was great. Thanks, Jared. One thing I did want to share here as well is that some of the stuff you were showing in that that was based on the sample that's in the examples and drivers. The what do you call it? You call it the end fed or something like that?
Yeah, more acronyms to confuse everybody.
Yeah, right.
But it's short for NRF 9160 Feather examples and drivers.
Yeah,
and
there we go. Yeah, so you have a repo where you actually have other stuff you pull in here, and then this is a lot of the setup here. I did notice the latch enable as well. Is that a specific call out for the GPIO versus like a tri-state type thing?
That actually, so that's a remnant from the other boards, the earlier versions.
Okay.
So that's one thing that also changed was I was using a GPIO to essentially latch the device on. It was part of the RTC circuit of when I could turn it off completely, like turn off the power supply, and then if I wanted to turn it back on, that would be the pin that would hold it alive. So it's kind of this like hacky hardware thing to keep it running. So. In this case, it's not being used anymore with the V5 version, but you can still use that pin for anything you want. It's still connected. So
cool. Okay. Yeah, that's good to know. Yeah, and other like setup things here. It's interesting. Like, you know, as I've been learning Zephyr and Mike's been showing more about Zephyr, and you do your streams about Zephyr. You know, it's about finding these different, you know, modes and kind of activating them, understanding them, playing with them, that sort of thing. So yeah, this is a good way that people can go and kind of explore this specifically on the Feather board and try stuff out there.
Yep. And the only caveat I would add, and I'm sure Mike has some bits to say about it, but it's all dependent, and I've said this before, it's all dependent on who wrote the drivers and if they added the power management functionality API to their driver. So some drivers might be using a different mode. Instead of suspend, it's like shut down. They're actually different like entries in that macro. So you just got to make sure that you're using the right one, because if you don't see anything happen, it might not be supported or you might not be using the right one. So
Jared, when you work with that, do you usually make like a function that just runs all of those commands for the sleep and all the commands for the wake? Or do you have another approach for it?
I mean, generally I typically don't use the PM device API unless I'm doing something kind of different in runtime. So for like, I would disable the UART if maybe it's being used at the beginning, or maybe it's used for provisioning and then I'm turning it off later, or the default state is off. But in general, I'm not really using that device, the device API very often. I try to let whoever wrote the drivers at Nordic kind of let it manage itself. So it's only for these like special edge cases where you want to use it, you want to turn it on for some amount of time and then turn it off. Like for instance, like I didn't really have to run the I2C power off command at all. It probably wouldn't make much of a difference in this application actually, but it's there just to show people, hey, you know, you can turn this off.
I think we'll talk about that a little bit more in the software section when we talk about like dealing with devices in the field.
Definitely. And one last thing I wanted to point out is actually a good segue into the next section, which is PSM required and EDRX required, which is something Jared calls out in his sample here. And that's what we're about to switch into here. You're about to see me in a different shirt at a different time at a different location. So prepare yourselves. Here we go.
Show you how I am measuring and also. All right, I'm here to show you a little bench testing. I am at my bench right now, and I'm going to show you how I am measuring and also what some of the output is from a device as I'm using something called the modem shell. This is a Nordic Semiconductor NRF 9160 program that you can basically download. It's a sample. You could compile it, put it on your device, and then you'll see some of the outputs I have here. If you'll excuse the shakiness here, I'm going to show you my setup real quick. So I do have a dual scope, JF220, which is the new version. So I'm monitoring current here and voltage here. The voltage I'm just monitoring on the pins of this of the header on the SparkFun Thing Plus 9160, which is the baby brother to the wonderful Circuit Dojo under Feather NRF 9160. And then for how I'm actually doing the measurement here, it's a little bit how you doing? But So what we have is basically I took a cable, I just cut the 5-volt line, and I'm just monitoring the current in line. So that's going, the red and the black are going back to my joule scope. And then, like I said, the red and the black here are monitoring the voltage on the 5-volt. We're not really using the 5-volt. It should be relatively stable here. So, okay, we're going to go and take a look at what the actual output of this is. And so let's switch over to that. So on the left side here, I have my joule scope. And you'll see, it's not doing much right now. On the right side, you see this is just a terminal. I can go and type help, and this is the modem shell. I wish that was a little bit bigger. Let's see if this, maybe that'll look a little better there. There we go. That's a little better. Okay. So you can see a couple blips here. I think that's actually just from me touching things. But the main thing you'll notice is that it's at 26 milliamps. And you might be thinking, actually, that is not very low current. And you were correct. I have not done anything else to this. I'm just using the modem shell, which means it's powering off at 5 volts. So the battery charger is just out there flapping in the wind. This is an older version, so it doesn't have the new hardware that Jared's talking about. And the other peripherals are on board are just all running. They're just free running basically. So let's show one of the first things that we talked about here with the UART, or maybe we have not yet talked about it, but because this is a test program, you can go and do, you can say UART disable in just 5 seconds. You should see, yeah, it just dips down a little bit there. So the UART does take about 500 microamps up to a milliamp, and you just disable that. You can see the disabled UARTs there. Okay, cool. That's good to see here, but like I said, there is still a lot here. What I really want to show is what it looks like when you're connecting to a tower, and then ultimately what we can do to try and modify those connections, basically. So let's do that. First thing we're going to do is say link fun mode, because this is fun, and we're going to turn it on. Right now it's been in the off state. And so we get to see here, and this is why I've kind of got it zoomed out. You see basically this is the amount of current that it takes to go and talk to a tower. And you see I'm at AT&T, the tower operator. You can go and see I'm in Durham, North Carolina. I'm on a hologram SIM card, and I have a DNS address. We'll be pinging that a little bit later as well. We are running LTE-M as well. I don't believe I have any NB-IoT in the area. There is some stuff you could try, but I am not doing that here. What you also see though is that this thing is pinging the tower once every second or so. And that is costly, right? So if your device is always going saying, hey, any messages? Hey, any messages? That's great for responsiveness, but not as great for power, which is what we're talking about here. So let's go and talk about some of the things that we can do to actually make this happen. Almost all the things you want to be doing if you are using the modem shell is in the link menu. And so you see that there's EDRX and PSM, and those are the two things we're going to be using here. There's also RAI, which I believe is tied to NB-IoT. I have not tried that yet, but there's other settings I really just haven't played in here. I've mostly been just trying to figure out, hey, how can I showcase some of the power saving modes in EDRX here? So first thing, let's talk about EDRX. EDRX stands for Extended Discontinuous Reception. And there was a former DRX that was a setting that you could do where it was kind of a fixed window. Now it's actually, you get to tell the tower, hey, I'm going to be awake in 80 seconds from now. Give me a shout, And so basically you actually tell the tower, here's my sleep modes, here's my window that I'm going to be back on. So let's go and actually try that here and see what that looks like. All right, so the first thing I'm going to do is do the link menu. Oops, sorry. It's popping up there. Link, and then EDRX, then E for enable. You need to say LTE-M in order to, well, and actually, let's just look at this real quick. So here's the menu for it. So EDRX, these are the different values that you can insert in here. But you do need to call out LTE-M, or else it's not gonna work for you. So link EDRX, E for enable, -- LTE-M, and then we're going to set the custom value here for X, EDRX value, and then the paging time window. So those are two things we're going to do, and these are actually values you can go and look up. But you'll see what these are here. These are just binary values. Oops, 1101. There we go. And so what you see is it's actually going and it's reconnecting the tower here. I can give it a little bit more headroom. So you see there is a cost to go and connect to the tower. But what we're saying is basically we're gonna be off for 20.5 seconds, and then I'm gonna wake up and I'm gonna be available to be pinged for 6.4 seconds. So what we should see here is in about 20.4 seconds, you see there's a 6.4 second window where it now goes and talks to the tower, and then it's back asleep. We can go and modify this window as well. So we can just kind of freehand this and say, actually, let's do a longer window, and let's do a a longer EDRX, shorter window, right? So now we're basically saying every 60 seconds, I'm going to be available for 3.84 seconds. All right, this might be kind of boring to go and do that. So while we do that, I'll go and tell you about the other thing that is available here, which is what we're going to switch to next, which is power saving mode. And let's talk a little bit about where these are good and useful in the first place. I'm going to keep an eye over here just to make sure I don't miss this window. So the first thing, like I said, it does keep in touch with the tower. Another thing that's important is there's less wake-up current. So basically, it's got kind of like a low power mode, ready to go, ready to talk to the tower. It's more responsive. And so I think about this, EDRX is good for listening devices. So something that's got to respond. Say you have, maybe a safety critical system, more likely, something that's just maybe like a door lock, right? You want it to be low power. Oh, and I'm going to switch back here. So it did just wake up, should just be going for a very short period here, just that 3.84 seconds, and back asleep again for another 60. Sorry about the interruption, but that's what it does, right? So something like a door lock where it wants to listen maybe on a shorter window. Maybe you don't need to have super responsive door locks. Maybe you do, and you might want to, you need to burn more power there. That's going to be one of the trade-offs you have there. But in this case, maybe a door lock's not a good example. Maybe it's something more like a industrial relay that just really doesn't have that much time sensitivity there. And so you can go and set it at a longer window there. So like I said, this is still listening to the tower. There's a little bit more current in order to do that. And obviously it's connecting more often. But it's still listening to the network on a relatively regular basis. Now the alternative here, and I'm about to see another window pop up. I think I'll switch over to that. The alternative here is PSM. So there's that window once again. Okay, yes, I've proven that the device, NRF9160, has a wonderful clock and talks to the towers properly. So that's one way you could save it, EDRX. The other thing we're going to talk about here is PSM. So let's go and turn that on. So first off, let's just go back. We're just going to turn off EDRX. So let's do that first, EDRX, and we're going to disable it. We should just see, now it's just saying, hey, I'm freewheeling here. I'm going to go back into checking the tower every once a second or so. Now, and I am doing this through the modem shell, as we've been talking about here. The way you're actually going to do this within a Zephyr program is actually going to be either through the API or you're going to issue AT commands. We're not going to do that here because the modem shell is nice and easy. And it's also, I wanted to show you this so that you could go and try it yourself as well, just to try out the different modes and see how things go. Okay, let's talk about PSM though, right? So now we're back to talking to the tower every second or so. Another thing we want to do though is maybe do a longer window. And so this would be better for something like a quote unquote talking device, right? So something that's like a sensor where it's just out in the middle of a field and all it needs to do is report once a day, every 6 hours, very, very long windows there. And all it's doing is pushing a little bit of data, going back to sleep. That's where PSM is probably going to be more of a winner. It's going to be a little bit more onerous to connect to the tower again, so a little bit more current when you're going to reconnect to the tower. So got to keep that in mind. You're going to have to do your spreadsheets to see, if it takes 100 milliamps to connect to the tower, maybe that's not worth it if your window is shorter there. So you really have to balance the length of the window versus the current it takes to reconnect to the device. Okay, so like I said, this is better for talking devices. I've been doing enough talking here. Let's go and actually make this thing happen. So I'm going to actually just copy this in here because it does have a longer string. So I'm going to copy this in here. So we see link PSME actually. Oh, geez. Why don't we just look at the text first? All right. And that is what our different things are available here. You have tau, and then you have the requested active time. So what I'm going to do, just insert again. So I'm going to set it like this. So we see the tau is 14,400, much longer, and then the active time is here. What I'm going to also do is actually, I'm just going to go and do something active here. I'm going to go and say, hey, go ping the DNS server, like I said I was going to do. All right, so we're going to see this is a costly thing, but this is an active thing that I'm doing, and then that should restart that window again. Now it's saying, hey, now I have another 16 seconds where I'm active again. And then what we should see is we should see this thing go back to sleep. And again, the sleep is the simulated sleep. It's just the flat line at 26 milliamps, everything else that's on there. But we should see it no longer pings the tower. And there we go. Now it's back to flatlining, and this thing will wake up in a very long time from now. So like I said, this is good for things like talking devices. We often talk about ag tech, smart farms, those kind of things. Things that, maybe even are, like just sensor networks generally. Those are going to have a really long timeline, and it's going to be better there. So those are two of the different modes you have available to you. You can go and check those out using the modem shell. Hopefully this is a good little use case here. We love the Joulescope. It's great for measuring. This is all a proxy, of course, because we're just kind of measuring the current going through the USB cable. There's more precise methods we can do elsewhere.
Haha, thanks, Chris. Back to me. Sorry, I've always wanted to do that. Yeah, I mean, if you're not going to treat a webinar like a infomercial, what are you going to do here, right? Looks like we had some really great comments in here as well. Probably stuff that we're going to pick up in the FAQ. We're going to go one last section here about software, which Mike's going to take on, and then we are going to be getting to the Q&A section. So take it away, Mike.
Right. So now we've talked about like hardware design, optimization, and firmware optimization, but ultimately, since it's an Internet of Things device, you're going to want to connect it somewhere, connect it to the cloud. And if you don't also think about your power use for that aspect of it, you are going to have a bad time. So one of the things that I think is really interesting is all these things that we've talked about so far, I guess, other than the hardware design, but using the firmware library, deciding what type of connection you're going to have. These are things that are configurable at runtime depending on how you architect your firmware. And so one of the things that you should never do is think to yourself, I have come up with every possible thing that could happen to my device in the field, and I'm going to ship my firmware and it's going to be great. Of course, you can push out over-the-air updates to make changes, but I think also design in mind that you might want to turn things on later on, maybe at the individual device level if you need to. So for instance, Jared was talking about calling the power management APIs. Maybe by default, things are in the lowest power mode, but you should be able to turn them or change that remotely. And so like one of the things that Golioth offers is the ability to issue remote procedure calls. So you could call functions that are on your device in order to change the state of, for say, debugging, change the state of those devices. The other thing that we offer is a settings service, and that settings service can be like fleet-wide. It can be by blueprints, like groups of devices, or it can be down to the individual device. So you might have everything in low power mode, and you have one node that's got some fishy data coming back, or it's not reporting in as often as it should, and you want to do some debugging. Building into your firmware the ability to toggle these remotely is going to prevent a site visit, which should be kind of at the top of your goals list when putting fleets out in the field. So I think about those design goals and think about those design practices. The other thing that I think about is just getting the device to do less work. So think about how you're going to be pushing sensor data, other readings back up to the cloud, and pick the best method for it. So like at Golioth, we offer LightDB State and LightDB Stream services. So Stream is like time series data that's going to be, oh yeah, I have slides I should be looking at. Don't worry, Chris, I'll get back to that. We have the LightDB State and LightDB Stream services. So if you have like sensor data that's going up to the cloud, you don't want to spend very much time processing that if you can on the device, because that's going to be intensive. What you want to do is package it up and get it to the service as quickly as you can. And so just try and do less on the device, have the device in power down mode more frequently. And that brings us to the other issue, which is like radio on time. That's going to be the biggest drain of your batteries, or radio on time. Chris was just talking about that with the sleep modes for the cellular, but also in how long you're going to actually be transmitting something. So if you have data that's going to be going up to the cloud, the two transport options for protocols that people often think about are MQTT and CoAP. Most people have heard of MQTT. I think to less of an extent, people have heard of CoAP. But there is a difference between the two, and you should consider them carefully. So MQTT is TCP based, and it's going to have a little bit higher overhead to kind of squash those packets down. At Golioth, we use CoAP, which gets them a little bit smaller, the UDP based protocol. And then we also have the option of using CBOR serialization. So even within, that once the data, if you send it when you're prototyping in JSON, that takes up a certain amount of space. But if you decide to go to production with it, you probably want to switch it over to a serialization scheme. We have CBOR in order to smash that down, so you have even fewer CoAP packets. And that all translates, like I said, to having the radio on for a shorter period of time for each data burst that you're pushing out. I guess the side effect of that too is you save money on bandwidth because you're probably paying by byte with your cell provider as well. So oftentimes CoAP's the better choice in that instance.
Yes, definitely. I think just you think about the length of any message that's going out, and Mike was just showing what was that debug method you were showing where we print out the whole CoAP packet? What was that called?
Oh yeah, the hex dump.
The hex dump.
The one?
Yeah. So you can actually see the size of the packet with what's in there, and then basically you can almost measure on the screen. If you're doing debug like that, you can measure on the screen. The taller that is, the more data you're sending, right? I mean, there's always the overhead on top of it as well, but you just think about the amount of data you're sending back. Another thing I wanted to say around the data you're sending back is kind of we utilize a lot of the built-in Zephyr stuff. So Zephyr logging, we tied Zephyr logging into our logging backend. Did you mention that already, Mike, or no?
Yeah, so your log messages, you can turn them on or off in Zephyr, obviously by the log level, but then you also with Golioth have the option of having those forwarded to the cloud as well. So everything you normally see when you have a serial connection to the device on your bench, you could have that coming up to the Golioth cloud. You're definitely going to want to turn that off by default because there's no reason to send all that data, but the ability to then turn that on remotely for the devices that are giving you, like I said, fishy readings or they're not checking in as often as they are is really crucial in kind of figuring out what's going on. And again, saving your company that site visit to plug a cable into the device and try to get data from it.
That's right. Yeah. And so I'm showing on the screen here, this is what the Golioth logging looks like. There's different log levels that you can have in your actual Zephyr program. You can then go and select, just show me the warn levels, just show me the, errors, just show me the info, that sort of thing. And then in Zephyr, Jared has videos about menu config as well. You can go in there, you can view what your log settings are like. You can obviously do this in your prj.confs as well. But, and then you can start to selectively turn that down. Another thing you could do is you could write some of your own code if you wanted to pull the device. This is a bad example. This is just this is a test project. I probably should have shown a different project here, but you could put a logging level. You could set it over the Golioth settings service and then change it dynamically on the device. So you're saying, hey, go turn on your debug logging so that you're only sending back debug messages on the select devices you want to. Because like Mike said, you might want to be sending just the warn and error messages for your whole fleet to really knock down the amount of logging messages. But then an individual device, you can go and specifically change a value just for that one device because we're showing just the detailed device view here. So this is some of the stuff that the Golioth console actually helps you to do when you're tied into each individual device. This is showing a different thing here, but something like the logging level, you could also set that up as a setting. One thing Mike and I were actually brainstorming about as well is you could even go and set up EDRX and PSM settings. You could put a Golioth setting in there. You could have processing on your device side. So now I say, hey, change the window from on-time window from 2 seconds to 6 seconds because I need to have more capabilities here, or I need a larger EDRX window. You could actually go and selectively set that. You would have to write some device side code in Zephyr, but you can very, very easily push that setting from the Golioth console, either from the console, the UI like you're seeing here, or the REST API that we have. You can push all that stuff to one device, all of the blueprints of a device, or to your entire fleet. So that's a really powerful thing that we've been using a lot in our samples. That's been really useful.
And of course, you can have like a pre-configured debug suite in your app. So you have like a function that turns everything on just the way that you usually like it for troubleshooting, and then call that with a remote procedure call just to get the misbehaving devices sending you back as much telemetry as you can get.
That's right. Yep. Mike, you want to explain a remote procedure call real quick too, so people understand what that is?
Yeah, so Chris has got the page up here. So basically you, in your firmware, you give a function a special name, and that's what the method box is in here. So in that method box, why don't you type in, I don't know, power management. This is going to call the power management function that's in your code. And then there's an add parameters button below. And that might be like the timing for the EDRX that Chris was showing, or it might be like the power management savings that Jared was talking about. Like whatever configuration that you're going to want, you can set them up. But I like it because if you don't know what parameters you need to pass for that particular function at compile time when the devices go out into the field, you can still send them here. And then as you can see, this doesn't exist on whatever test device this is that Chris has.
Right.
So it actually gives them feedback like, hey, we sent it to the device and we couldn't get the device to report back to us. So like that tells you something there as well. So normally if the device is on and running and listening for the RPC, you'll get a green success, and it'll also give you a payload. So the device can send stuff back. So you could send it out and say, hey, why don't you run those modem testing features that we saw in the modem shell? Why don't you send that information back to me? And so you can, like remotely access the information on the network and maybe even do a survey and be like, oh, can I tweak this a little bit more so that, I'm not taking so much time to connect to the cell towers. There's something I can do that can, get me out of the bind that I'm in.
Yeah. And then I think the last thing is like, say you want to implement a new RPC, a new setting, a new logging setup or LightDB stream. In all of these cases, you can go and push a new firmware update to the devices. Super easy. Just go and deploy to one device, many devices in your fleet. So it's another very critical thing that we think can help you to optimize a lot of your device deployment.
Yeah, set OTA up first, because anything else that you forget to do later, you can fix with OTA.
That's right. That's right. Jared, what are some other things that you see when you're tweaking devices, either in the field or on your bench, that like the cloud side could actually help with?
I mean, you guys already hit most of the important parts. It's just like config management, either sending it out down to the device and then also getting current state of whatever the device is going on. That's kind of the big requirement that I've seen over and over and over again. Publishing that time series data, so publishing sensor data, another huge thing that's critical. You guys just touched on firmware over the air. Like Mike said, that's probably one of the first things that you want to get running. It's kind of like a rule of thumb every time I'm creating a new product, is you got to get photo working immediately. And the nice thing about Golioth and Zephyr, it's already done for you. So you integrate it and it works. So those are kind of the biggest things that come to mind for me. I mean, having the ability to log to the cloud is also great, and then set the log levels is super useful, because then you don't have to be tethered to that device. You can look it up in the field and see what the heck is going on. It definitely takes. It's really beneficial. You don't have to get in a car and drive a couple hours just to see what's going on with it.
Man, there's nothing worse than when you get there and the main thing you have to do is just push the button, push the reset or something, like, oh boy, so. Yep. Yeah, even a RPC that we often push in as our default is a reset RPC, like have it send it a reset, and boy, that's useful. All right, let's go into the Q&A section. People can go and ask questions in the chat here. We do have some ones that we've saved, so I'll put those up on screen as we ask them. And I know we are nearly at the hour mark. We're going to go a little bit over, but feel free to drop stuff in here. So let's get started here. What is the reason for removing the RTC timer circuit?
It's not completely removed, actually. It's still there.
Oh, okay.
The only thing that is removed was the added capability for the RTC to basically wake up the power supply to turn on the NRF9160 again.
Got it. Got it. So now it just pulls a pin back low or something instead of actually triggering the power supply system.
Correct. So that interrupt is still there. So you can still interrupt on timers and counter events and things like that on the external RTC. It just won't change anything with the state of your power supply. And that's because
Great.
I just like it was complicated. It made testing a little hairy. And now that the device draws significantly less current in the active sleep state, it was almost not worth it. So
Yeah.
I know some people really love like the crazy shutdown mode, but the nice thing is your hardware that you plug it into, you can do the same thing. So it's not
Yeah,
like the end of
that's
the
right.
world. So
Yep. Yep. Okay, great. What about is there a battery fuel cell monitor? And if so, what does the support integration look like in Zephyr? I think that's specifically on the Feather board.
okay, yeah, I wasn't sure. There is no battery fuel cell monitor. Those actually do draw a fair amount of quiescent current. Last time I looked into integrating one, so that's something you got to keep in mind, especially for long running, low power operations. This board doesn't have one, but I'm sure, I don't know if you guys have seen any drivers or anything in there for a battery, a fuel cell monitor. But I'm sure it does exist in Zephyr. There's pretty much everything you could think of in the Zephyr repository.
I have seen one or two, but I think a key point to call out is if you're starting from scratch, one thing that Mike and I do is we often go and like just look in the driver folder, because if you can find, so like Jared mentioned, there's a lot of shortages right now, but if you can find a chip that fits your needs, has a Zephyr driver, and is available, boy, your life gets easy. Like
Bingo.
yeah.
Another quick tip too is to search GitHub. So for people like me who are still working on a driver, or maybe it's kind of set, but maybe they haven't added it to the committed it to the Zephyr repo. I have a couple drivers that I have, so definitely search for GitHub for like Zephyr and then the name of the chip, because you might be able to find it too if it's not in the main repo.
Great. Okay. Oh, how do I unfavorite that one? Oh boy. See if I can get it off here. There we go. Okay, great. Nope.
Sorry, I
Come on,
clicked it
Chris.
too.
Aha, I see.
Yeah.
I see. Let's go to Charles. So I noticed in Chris's video that there was no NB IoT coverage there. Is it still limited in the US? So some of that is my old, I used to work at Hologram, and that was when NB-IoT was getting more. That was like, I think they had their first test site. It actually is more widely available than I thought. So mine is just kind of like that response. The answer would be go check the charts yourself, and there's coverage maps all over the place. And then once you do that, then you can go and use something like the modem shell to actually see if there is local coverage. LTEM I've seen is widely used. So I think if you want some of the extra low power modes for NB, I think you would probably want to do a little more research on that sort of thing. Jared, Mike, I'm not sure if you guys have other thoughts about this.
So I know that there's one provider here in the US that has a more extensive NB network. The only problem is it's not. Last time I looked at it, this particular chip was not supported on that network. So usually how this stuff works is Nordic goes to talk to these particular vendors, and then they get the sign off, and then they allow those IMEIs to kind of roam on their networks. So last time I checked, it wasn't supported, but that might have changed recently. And I know we have some kind of network people here in the chat. So if anybody has any comments about that, let us know.
Yes. Yeah, and actually that's a good call out to Robert's comment here to check with your operator, because so I mentioned I used to work for Hologram. I'm using Hologram SIM cards right now, but that is roaming, right? So a lot of the MVNOs are doing roaming setups. Some of them are working directly with MNOs. So MVNO is mobile virtual network operator versus a mobile network operator. Usually the carriers in the US like T-Mobile, Verizon, AT&T, those are the MNOs. And then MVNOs are going to be people that usually buy excess capabilities through third parties, whatever. There are a lot of MVNOs out there. And like Robert calls out to go and check that, especially on the roaming side as well. So very good call outs from Robert. Thank you for that. And I think what it comes down to is you do need to test it. I think you can also talk to your MVNO and just see what they tell you. Yep. But trust but verify. I think that is that's the important thing here.
Yeah, it depends on the MVNO, but also the actual network you're connecting to. So if you're in Europe, in like a certain area of the world, it's really dependent on that particular network, not only just the MVNO. But great points. Robert actually works for Telenor, so he's in the know. Thanks,
Great.
Robert.
Chip brings up here. This is a comment rather than a question, but also just that you are going to have some diversity in your area. So if you're not super localized, I think a lot of operators kind of think local, whereas a lot of IoT deployments, especially industrial type stuff that might be across the country or across the world, there are a lot of testing requirements there that is definitely outside the scope of this presentation, but definitely check, and double check about what you need to do regulations wise, and then also what coverage you have, because you can really get yourself in trouble there.
And nothing beats actually going to the place where you want to deploy and actually testing it, because that's what you might have to do a site survey.
Yep. So this is a call out for Joao, who actually showed me a bunch of the modem shell stuff. So he's here as well. Thank you for being here. He's down in Brazil at one of the Nordic partners, BPNM. And he calls out the RAI as well for NB-IoT. So luckily I was right in that. I couldn't do it here because I was not on NB-IoT. So yes, very, very good thing to have. If you have NB-IoT coverage, you can try out RAI, which is awesome. So thank you, Joao. All right. Question from Chris Wilson. Mike, why don't you take this one?
Is the OTA already optimized for low power, minimal data usage cellular networks, or are there settings that should be configured, tuned to optimize? I'm not sure the answer to that question, Chris.
Well, I'll let you take it because I didn't know either. Jared, do you know? So one thing I'll say about
you're transferring. When I looked at the implementation a while back, I know you're essentially transferring those raw. So you're taking the image and you're splitting them up into chunks of data, and you're actually sending them over UDP over CoAP. And I think they're actually encoded as a CoAP or a CBOR package with some kind of metadata and also just like the bulk data. So if you find yourself,
one thing I will say though is we do not have differential updates yet. That's something we're looking into. So right now, if you have a 1 megabyte memory, you're going to be sending less than a megabyte because you need to have your partition so that you have half set up as a secondary type of thing there, but you are sending the entire firmware package. So from that perspective, it's not optimized for low power or minimal data. It is because it is that full firmware image right now. Hopefully in the future we'll have updates about how to reduce that as well. In terms of tuning to optimize, I think you probably would not want to be in a super low power mode for that sort of thing, right? Because you're just receiving chunks of data. That actually might be an interesting video. I might turn the jewel scope back on and see what that looks like when
I think while you're doing the data transfer, there isn't really any optimization. So the data usage optimization, yes, like that's if you're going to send the entire binary, it is packed down as small as it possibly can be. And then as far as how the device receives a notification of that, basically the device registers with Golioth, or the device can register with Golioth and say, hey, notify me whenever an update is available. And then you just receive that notification when something changes. The other thing you can do is you could set up the device so that the device decides when it asks Golioth, hey, is there a firmware update? So like other than those two instances, like getting the manifest to see if the update is different from what I'm running, or actually downloading the whole thing, those are the only time that you're actually using any power with the microcontroller for OTA.
Great. With other OTA implementations that I've seen in the past, you can definitely dictate the amount of data you can send over at one time. So like the blocks of data I was mentioning before. And also, some of them actually save progress, so you can actually terminate the download and then continue it later. I haven't looked at that recently, whether or not you guys have implemented that, but I know there are some things that you can do to work around that if you're in an area where you might not be able to download continuously.
Yep. Yeah, I think if I think about the Golioth Zephyr SDK at a high level, we optimize for usability first, and then like any so that you can get it working get the updates, that sort of thing. I think optimizing over time with your fleet, you might have to dig under the hood a little bit. We can obviously talk to you about that. We have a forum.golioth.io is always a great place to ask these kind of longer form questions and feature request type things as well. So we'd love to chat with you guys about that there. All right, winding down here. A couple more comments. Oh, here we go. Well, this is a link that Akam put in the chat. So that's useful. There's a GSMA thing there as well. So that's really good to go and look at that sort of thing. And Robert's got some comments in there about the availability of LTE-M versus NB-IoT as well. One other thing from Akam is in NCS 2.1. So that is the latest that I was using. I think 2.2 is in preview or maybe out. It's 2's out. Is that right, Jared?
Yeah, it's released.
Okay. Yeah. The Golioth SDK is still tested against 2.1. So we're one back right now, but I think we're pushing that new one soon. And so just availability of the PM in the power mode. So that's interesting about what's getting pulled forward from the actual device side of things. So, all right. And then one last thing would be Zhao again, talking about the Zephyr 3.x, right? So that's also where I think that's synchronized to NCS 2.x and forward, I believe is linked to Zephyr 3.x forward. I'm not sure where that transition actually happened, but basically, a lot of the things that happen in Zephyr also get pulled into the NCS stuff as well, which is great.
Yeah, usually it's a little bit behind, but they're always updating it and changing it. So
yeah. Okay, I think that's it. Thank you, everyone who attended here today. If you're watching this after the fact, you can always ask us questions at forum.golioth.io. We are always available there, and we love getting new questions. You can find us on social as well, often Golioth.iot_IoT, and we have different things there. Let's see. I think we have a slide for this as well. Oh, this is the wrong presentation thing here. Any final thoughts there, Jared?
If anybody has any questions related to the NFED directory or the hardware itself, you can go to community.jaredwolff.com and you can ask your questions there. And of course, I recommend y'all get in touch with Golioth if you're interested in making it a lot easier on yourself to get started with new projects in IoT for sure. And you can check me. You can give me a follow on Twitter, at Jared Wolff. So,
yes, we will continue to watch all the Zephyr 101 live streams. Those are a wonderful resource, and we are often tuning in for those. And we'll keep on using Featherboards. Thanks for making those, Jared. All right. Thanks everyone for being here, and we'll see you in the next webinar. Have a good day.
See ya.